Question number 6. Find the equivalent capacitance between P and N. Here, this is C1, C2, C3. Clearly, C2 and C3 are connected in parallel. So, C parallel will be C2 plus C3. Now, resultant of C2 and C3 is connected in series with C1. So, it is C1 in series with Cp. So 1 upon Cs will be equal to 1 upon C1 plus 1 upon Cp, which will be equal to C1 into Cp and Cp plus C1, which is 1 upon Cs. Thereby, Cs equal to C1 into Cp divided by Cp plus C1. We put the value of Cp, C1 times C2 plus C3 divided by C2 plus C3 plus C1. And that is our answer. Question number 7. Find the energy stored in a capacitor of capacitance 100 microfarad when it is charged to a potential difference of 20 volt. Energy stored in a capacitor is given by half CV square. So here half C is given as 100 microfarad, 10 to the power minus 6 into voltage is 20. So this will become half CV square. So here V20 will get squared. So this will become 50 multiplied by 10 to the power minus 6 times 400. So on simplification, we will get 2 into 10 to the power minus 2 joule. Question number 8. Two parallel plate capacitors are connected in series if place between one of them is filled with dielectric constant K equal to 4. Then what is the equivalent capacitance? Given C1, C2 are 40 microfarad. This is C1, this is C2, and place between the two plates is filled with dielectric constant K. We have to find out the equivalent capacitance. We know that capacitance increases K times when dielectric is filled between the plates. So C2 will be equal to K times C2 dash. Let's write it as C2 dash. K times C2. That is, K is 4 times 40 microfarad. Now, the two capacitances are connected in series. So we find 1 upon Cs equal to 1 upon C1 plus 1 upon C2 dash. So this gives C2 dash plus C1 divided by C1 into C2 dash, or Cs equal to C1 C2 dash divided by C2 dash plus C1. So C1 is 40 microfarad, 10 to the power minus 6 into, this is 4 into 40 into 10 to the power minus 6 farad divided by C2 dash is 160, 4 into 40 into 10 to the power minus 6 plus another one is 40 into 10 to the power minus 6. So here in numerator we will get 40, 50, 1600, 6400 into 10 to the power minus 12 divided by, in denominator it will be 200 into 10 to the power minus 6. So we can simplify 2 zeros, we consider this will become 32 and the power will be reduced by 6. So 32 into 10 to the power minus 6 farad or 32 microfarad. A parallel plate capacitor has plates of area A separated by distance d between them. The space between the plates is filled up to thickness x less than d with a dielectric constant k. Calculate the capacitance of the system. Here, these are two plates. Up to here, the place is filled with a dielectric constant k. This distance up to x, and the remaining distance d minus x is filled with air. Now we have to find out the combined capacitance of the system. So let's find out the capacitance of this portion, and then we will assume that they are connected in series. So let's take this as C1, this as C2. So C1 will be epsilon naught A times dielectric constant K divided by separation between the plates. So up to here, it is X. And C2. C2 is epsilon naught A divided by separation is D minus X. Now these two capacitances are connected in series. So we evaluate 1 upon Cs equal to 1 upon C1 plus 1 upon C2, or C1 C2 divided by C1 plus C2. So Cs is equal to C1 into C2 divided by C1 plus C2. We put the values. Epsilon naught A K divided by X times epsilon naught A divided by D minus X whole divided by epsilon naught A K divided by X plus epsilon naught A divided by D minus X. Now we can simplify. So on simplification, we will get K epsilon naught A divided by KD minus X times K minus 1, which is our answer. Thank you for watching.